Hi, my name is Bahadur Akhmedov. Welcome to the course of multivariable calculus. In this video, we're going to solve problems from a quiz on vector functions. We're going to solve 8 problems on the following topics. We're going to solve problems on the derivatives and the integration of the vector functions. And also, we're going to calculate the lengths of some vector functions, calculate the tangent vectors, normal vectors, and also the curvatures. So the first problem is we're given a vector function. We just need to find its derivative. So we need to know that the vector functions are going to coming with the components. So in this case, it has 3 components, but in general, they are given as an n tuple. They might come with n components. And if I would like to find the derivative of the vector function, we just need to take independently the derivative of each component. Basically, we're going to take the derivative of the first component, then the second component, then the third component, with respect to the t, of course. So the derivative of the first component is going to be sine of t plus t times cosine of t, according to the multiplication rule. So the derivative of the second component is t. The derivative of the third component is going to be cosine of 2t minus or plus t times the derivative of the cosine of 2t. It's going to be minus sine of 2t times the derivative of the 2t, which is going to be simply 2. So this is the derivative of this function. So in our next problem, we again need to find a derivative of the vector function. We're given the vector function in this form with the ijk notation, but we just need to know that hey, ijk, the coefficients before the I, j, and k are going to be just the components of this vector function. So basically, this is going to be the first component, minus 1 is the second component, and the plus ln of 1 plus 3t is the third component. And if I would like to find the derivative of the vector function, we just need to find its derivatives component wise. Basically, we're going to find the derivative of the first component. It's going to be e in the power of t squared times the derivative from the t squared, which is 2t. We just need to multiply this to the I. So derivative of the minus 1 here, the second component is minus 1 times j, right? So this is the second component, and derivative of the second component is simply 0. So we're going to write this as a plus 0 times j. So we are it doesn't mean that we are not we don't have the second component. It just means that this is equal to the 0. It's a number. It is equal to the 0. And the derivative of the third component is going to be plus 1 over 1 plus 3t times the derivative of the 3t, which is going to be simply 3, times k. So if I would like to write this derivative in the 3 tuple form, it is going to be 2t times e in the power of t squared, 0, 3, 1 plus 3t. Again, I need to mention that if your function is given as a 3 tuple, then its derivative should also be given as a 3 tuple. So let's go to the third problem. Problem number 3, we need to find a unit tangent vector. So the tangent vector is simply the derivative of the function, and the unit tangent vector is basically when we are making this vector as a unit by just dividing this to the norm of this vector. So I just need to mention that, hey, if you're just given any vector v, the vector a vector which is going to be in the same direction as this omega, but the unit vector u can be found by just dividing this omega to its norm. So basically, we first of all, so the direction is important because we can always normalize the length of the vector and make this unit. So that is why what we are going to do is we are going to first of all find the derivative. So the derivative of this vector function is going to be, so we are going to take the derivatives component wise. we're going to use the multiplication rule in order to find the derivative of the first component. It's going to be e in the power of minus t times t in the power of minus t. So please note that this minus is coming from the derivative of the e in the power of minus t. So the derivative of the arctangent is equal to the 1 over 1 plus t in a square, and the derivative of the t e in the power of t is going to be simply t e in the power of t. So I'm going to substitute t to be equal to the 0 first of all, and evaluate this vector at this position. It's going to be simply, so if I substitute 0 to the t, it's going to be 1, right? Because so e in the power of t is 1, this is going to be 0. If I substitute the 0 to here, it's going to be 2, and if I substitute the 0 to here, it's going to be 2. So the components of the derivative is going to be 1, 2, 2, and we need to uniform this. Basically, this is just some vector was the components 1, 2, 2. We need to find a vector in the same direction, but the unit one. In order to do this, we just need to find a norm of this vector and divide the norm to the vector itself. So basically, the norm of this vector, r prime of 0, and its norm is going to be equal to the square of the components and their sum under the square root. It's going to be 1 in the square plus 2 in the square plus 2 in the square, or basically it's going to be 1 plus 4 plus 4, which is 3, right? So I have to divide this 3 to all the components of this vector, so that the unit tangent vector is going to be r prime of 0 divided to the norm of the r prime of 0. So it's going to be still a vector, so I just need to divide all the 3 components to the 3. It's going to be 1 over 3, 2 over 3, and 2 over 3. So let's go to the problem number 4. Find a unit normal vector. So the unit normal vector is defined as, so we just need to find the unit tangent vector. We need to find its derivative. And then we have to normalize this so that it's also becoming a unit, and this vector is defined as a unit normal vector. So what we're going to do is we first of all are going to find just a normal vector, like tangent vector, then normal vector, and at the end we are going to normalize this. So please note that in order to find this, we don't need to normalize the tangent vector. So once you find a tangent vector, you don't need to make this unit and plug this to here. So it is possible to work with non-unit vectors here at this formula as well. Because at the end we're going to normalize this anyways. So let's find the tangent vector. It's going to be the derivative of this function, which is going to be 1 minus 3 sine of t, 3 cosine of t. So I'm just going to take this as the t prime, as the t of t. So I'm going to find the t prime of t, which is going to be derivative of the tangent vector, which is going to be 0 minus 3 cosine of t minus 3 sine of t. So now we need to basically normalize this. In order to do this, we are going to find its norm, so which is going to be 0 in a square plus 9 cosine square of t plus 9 sine square of t. If we take out the 9 out of the square root, we are just going to have sine square plus cosine square, which is equal to the 1, so it's going to be simply equal to the 3. So the unit normal vector is going to be the derivative of the tangent vector divided to the norm of the derivative of the tangent vector. So it's going to be 0 minus 3 cosine of t minus 3 sine of t divided to the 3, which is going to be simply equal to the 0 minus cosine of t minus sine of t. So let's go to the problem number 5 now, which is going to be about the integration of the vector functions. And again, the vector functions are given with the 3 components, and if we would like to evaluate the integration, we just need to integrate them separately, the components. So we are going to integrate the first component, then the second component, then the third component, and then we are going to just plug the 3 components into the resulting vector function. So the integration of the 3 sine square of t cosine square of t dt from 0 until pi over 3 can be done when we are making the notation. For example, sine of t is going to be u, then du is going to be cosine of t du, right? So we are going to substitute this part as a du, and this is going to be u in the square, for example. So it is going to be equal to the integration of the 3u squared du. Its integration is u cubed. We can just resubstitute this back. It's going to be sine cube of t. Now we just need to substitute the borders. The borders are from 0 until pi over 3. So please know that if you substitute the 0 to the sine, it's going to be simply 0. And pi over 3 of sine, so sine of pi over 3 is square root of 3 over 2, and a cube is going to be 3 square root of 3 over 8. So now we are going to integrate the second component. Integration of 3 sine of t cosine square of t dt. Again, we are making the notation. So the u in this case is going to be cosine of t, and du is going to be minus sine of t dt. And we're going to kind of substitute everything to here. It's going to be minus 3. So this and this is going to be minus du, right? So minus du. And the cosine square is going to be u in a square. Its integration is u cubed again with the minus. So it's going to be minus cosine cube of t. And we need to substitute the borders from 0 until pi over 3. From 0 until pi over 3. So cosine at the pi over 3 is 1 over 2. So its cube is going to be minus 1 over 8. Minus, so the cosine at the 0 is going to be 1, so it's going to be minus 1. So minus 1 in the cube is minus 1 as well. So it's going to be 1 minus 1 over 8 is going to be 7 over 8. So this is the second component for resulting vector function. And in order to find the third component, we just need to integrate the 2 sine of t cosine of t, 2 sine of t cosine of t dt. Well, there are a lot of ways to integrate this function. We can either substitute u to be equal to sine of t, then du is going to be cosine of t, but you can take u to be equal to the cosine and you're going to get the same result, or you can use the the formula of the double angle for the sine, and you're going to get the same result in all the 3 cases. So it's going to be u here, and this is du. So it's going to be 2u du. Its integration is a u squared, so which is going to be sine square of t, and we need to substitute the borders from 0 until pi over 3. So at the pi over 3, sine is equal to the square root of 3 over 2. It's going to be 3 over 4, right? So now we've got all the components. So the integration of this function dt from 0 until pi over 3 is going to be again a vector function. What was the components? The first component, if you remember, it was 3 square root of 3 over 8. The second is 7 over 8, and the third is 3 over 4. So this is problem number 5. So let's go to the problem number 6, when we need to find the length of the curve. So the length of the curve is found using the following formula. So we need to integrate from a to the b the norm of the derivative of the function, of the given function. So we basically first of all need to find the derivative, then find its norm, and then integrate this. So again, we are going to have a vector function with the 3 components. This is the first, second, and third components. We can take their derivatives separately. So the derivative of the r of t is going to be So this is t times square root of t, right? So it's going to be simply square root of 2. So e in the power of t is going to be e in the power of t, and e in the power of minus t is going to be minus e in the power of minus t. So we need to find its norm. So the norm of the r prime of t is going to be 2 plus e in the power of 2t plus e in the power of minus 2t from the square root. So what I'm going to do is I'm going to give the common denominator, because e in the power of minus 2t can be written as a 1 over e in the power of 2t. So if we give the common denominator, it's going to be e in the power of 4t, right? So if you just multiply e in the power of 2 to the e in the power of 2 to this term, it's going to be e in the power of 4t plus 2 e in the power of 2t plus 1 divided to the e in the power of 2t. Please note that the numerator can be written as a e in the power of 2t plus 1 in the square. So divided to the t, e in the power of t in the square, right? From the square root, it is going to be equal to the e in the power of 2t divided to the e in the power of t. It's going to be e in the power of t plus e in the power of minus t. Good. So we just need to integrate this function with respect to the t from 0 to the 1. So a in our case is 0 and b in our case is 1. So we are going to integrate this function e in the power of t plus e in the power of minus t from 0 to the 1 with respect to the t. Its integration is going to be e in the power of t minus e in the power of minus t from 0 to the 1. So if we substitute the 1, it's going to be e minus e in the power of minus 1. So if you substitute the 0, it's going to be simply 0, right? Because it's going to be minus 1 plus 1. So this is going to be e in the square minus 1 divided to the e. So this is the answer. So the length of the curve from 0 to the 1 is going to be equal to this value. So let's go to the problem number 7. So in this problem, we need to find the curvature. So in order to find the curvature, we need to, it appears, divide the norm of the unit, the norm of the normal vector, not necessarily unit normal vector, divided to the norm of the tangent vector. So let's find first of all r prime of t. So r prime of t is going to be equal to the 3, 4 cosine of t minus 4 sine of t. So we need to find the t, the tangent. So this is the tangent vector. But the t of, so but at the same time, this is the unit tangent vector. So if you remember, the unit tangent vector means we need to find r prime of t and divide it to its norm. So the norm of the r prime of t is going to be equal to 3 in the square, which is 9, plus 16 cosine square of t plus 16 sine square of t from the square root. So it's going to be equal to the 5, obviously. So the t of t, it's going to be equal to the 3 over 5, 4 over 5 cosine of t minus 4 over 5 sine of t. So again, what we need is, we need the derivative of this function and its norm. So the derivative of this function is going to be equal to 0 minus 4 over 5 sine of t minus 4 over 5 cosine of t. So if you find the norm of this function, it's going to be equal to 0 in the square plus 4 over 5 in the square, which is 16 over 25 sine square, right? Sine in the square of t plus 16 over 25 cosine square of t. So if you basically take out 16 over 25 from the brackets, it's going to be 16 over 25. From the square root, it's going to be 4 over 5. What we're going to have inside The brackets are simply sine square plus cosine square, which is equal to the 1. So now we just need to substitute this values to here. So the t prime of t is 4 over 5, sorry, divided to, and r prime and its norm is equal to the 5. So the answer is equal to the 4 over 25. And our last problem is again about finding the curvature at a given point. We are given a vector function. We need to find a curvature at some point, and we are going to use now another formula. So it's going to be r prime of t cross product is the r t prime of t and its norm divided to the norm of the r prime of t in the cube. So if you as you mentioned, we need the ingredients of this formula. We basically need the r prime of t. So it's going to be equal to 1, 2t, and 3t in the square. And the second derivative as well. So the second derivative is going to be 0, 2, and 6t. Now we need to multiply them as a cross product, and if you remember, this multiplication can be obtained by finding the derivative of this function of this matrix ijk. Then we need to put the components of the first vector as the second row of this matrix. That is 1, 2t, 3t in a square. Then we're going to put the components of the second vector as the third row of this matrix. It's going to be 2, 0, 2, 6t. And we are going to find the determinant of this matrix by just going through the first row, for example. We choose the first component and just raise the column and the row where it is located. Basically, I is going to be multiplied to the determinant of this matrix, which is left, which is going to be 12t in a square minus 6t in a square. So then we are going to go to the j. So we are going to just erase the column and the row where the j is located. Minus j is now multiplied to the determinant of the matrix, which is left, which is going to be 1 times 6t, which is 60, minus 0 times 3t in a square, which is going to be simply 0. And then when we go to the k, we're going to make the similar manipulations. We're going to just delete the row and the column where the k is located and multiply this to the determinant of the matrix, which is left, which is going to be simply 2. So we are going to just write down this component wise. It is going to be equal to the 6t in a square minus 6t and plus 2. So this is the cross product of these two vectors. We need the norm of this. So the norm of the r prime of t cross product is r t prime of t is going to be equal to the 36t to the power of 4 plus 36t to the power of square plus 4. And actually, we don't need to do any manipulations because we need to just evaluate this at some value for the t. So we need to find the curvature at this point, right? So, and you can obtain this point by substituting to the vector function t to be equal to the 1. So if you substitute t to be equal to the 1, you're going to get this point. So that is why we need to evaluate all of these functions here at the t to be equal to the 1. So let's substitute this. So if you remember, it was equal to 36t to the power of 4, 36t to the power of 4 plus 36t to the power of 2 plus 4 divided to the length of the vector r prime of t. So the length of this vector can be found as the square root of 1 plus 4t plus 9t in the power of 4, right? And this is in the cube. Good. So we are just going to substitute t to be equal to 1 to here. It's going to be 36 plus 36 plus 4 from the square root. And here we're going to have 1 plus 4 plus 9 in the cube. It is going to be equal to the square root of 76 divided to the 14 in the power of 3 over 2. So this is the curvature to this vector function at this point. So these are all the problems on the quiz for the vector functions.